So what we're going to begin or continue talking about is just putting together the graphs of sine and cosine functions. And so already we've talked about the period and how you can find the 5 critical points on the period by cutting it in half and then cutting those halves in halves, right, by finding the quarters of that to get your 5 critical points. And what we're going to look at here today are and we looked at the phase shifting. What we're going to look at today here are the capital A value, the amplitude, the multiplier in front, what that does to it, and the midline. Okay? So to look at the midline first, if you think about the graph of a sine or a cosine, remember what happens is the graph is going to oscillate about a midline. Okay, so you're going to have some midline. There's not going to be a physical line drawn there, but it is. I will use a dashed line here just to represent what it refers to. But your graph is going to oscillate back and forth but from this midline. Okay, and the oscillation is going to go up 1 amplitude and down 1 amplitude. So the distance between the midline and the maximum point or the minimum point is what your amplitude is. So when you're finding the midline from a set of points, okay, you might be given a minimum, you might be given a maximum, you might be given an amplitude, and you might be given what the actual midline is, and you need to find one of those pieces of information. Okay, so the 2 examples that you're going to see here are what if they give you a minimum and an amplitude? Well, when you look at how this is set up, your minimums are down here and your maximums are up here. Okay? The distance between the minimum and the midline is that amplitude. So when you take a look at this, the midline plus the amplitude is equal to your maximum point. And if you take your midline and subtract the amplitude, you get your minimum value. So you're kind of looking at this relationship here for the first set. There's another relationship here that works, and that is if you were given the maximum and the minimum, the midline is the average of those. And so you can also say here, like basically if you just add straight down the columns that I've written up here. So here you have 2 midlines. Here the A's cancel, and then you have the max plus the minimum. What you see here would be that if you had 2 midlines, so I'm just solving a system of equations here, right? The A's cancel, and then the max plus the minimum. And if you divide by 2, you get your midline. So your other equation that you could use is the midline is equal to the max plus the minimum divided by 2, or the average of those. Okay, so these are the 3 sort of formulas that you can use based on the information provided. Okay, so I want you just really quickly, see if you can use that to calculate this midline. The midline is an equation, y equals, in this one, it's the d value, right, in just the generic form of the sine and cosine functions. It's that vertical shift of your function. But see if you can find what that equation would be. So again, if you know that your midline minus the amplitude of 6.4, okay, you can put absolute values there. It'll always be, amplitude is always a magnitude, a positive value. And that's going to equal your minimum, which we know. Now, when we are finding the minimum, are we looking for the x-coordinate or y-coordinate? The minimum is the y value. So we're going to use 9.5. And so here to solve this, we simply add 6.4 to both sides. And we get the midline is equal to 15.9. And that is our equation, right? Y equals 15.9. That's where the midline's going to be. And then the graph oscillates about that. So all of again, the midlines are there. The max and mins are going to be 6.4 above or 6.4 below that given line. All right, I want you to try the second one. In this second example here, you're given both the max and min, and see if you can find what would the midline be if that's the information that was provided. Again, since midline is a y equals relationship, you're looking at the y values. So here, if you're told the max and min, the midline is going to be their average. So the maximum is negative 1/3 or negative 1.3 plus your minimum is a negative 2.7. And so we want to find the average of these. So we add them together and then divide by 2. So when you combine those, you get a negative 4/2, and that reduces to a negative 2. So y equals negative 2. That's going to be the equation that represents your midline. Okay. Right. So now, using these same relationships here, you can find your, or same types of relationships, you can find the amplitude. Okay, it's the same idea, right? When you take your graph and you have a midline. So that's your y equals d form. Your graph is going to oscillate about these in the same height. Those are your amplitudes. Okay, so if you know that you have a maximum here and a minimum here, what you can do is you can find the amplitude by either knowing the midline is d, the amplitude is going to be the distance from the midline to the max and to the min, or it's going to be halfway between the max and min. Okay, so it could also be found by taking the midpoint of the max and min, right? And so when you're calculating the amplitude is either going to be the distance between those, so the max minus the minimum, divided by 2. Okay, so again, the total distance is the max minus the minimum, and we want the halfway point between that, so that's going to divide by 2. Okay, you can also find the amplitude by taking the absolute value of the distance from the maximum to the midline. Okay, or the midline to the minimum. And now both of these are, again, magnitude values. So the absolute value just means we're looking at a positive distance for those. So you're never going to get negatives. The negative sign in front of the a when you're looking at your equation just has to do with the reflection of the graph. And we'll talk about that when we get into the sketching of the graphs. Okay. So once again, if you're looking at these possible equation forms to find your amplitude, I want you to see, can you take this first example here and find what is the amplitude between those given points. So amplitude refers to a vertical component. So we're looking at the y's here. So we look at these y coordinates. And since we're given the max and the min, we can use this first relationship where the amplitude is equal to the maximum value, or the absolute value here, of the negative 3.1 minus the minimum value, negative 6.1, all over 2, because we're finding the middle point. It's half of that total distance. Okay, and so when we calculate this, minus a minus becomes a plus. Okay, we get a total of 3 over 2, and that would be our amplitude. So the amplitude is just a value, right? It's not an equation. And so 3/2 is going to be that multiplier in front of our function. And again, that's the distance from the maximum to the midline and from the minimum to the midline. Okay, so do this final one here. If you're told what the midline is and you're given a maximum, okay, see if you can find what would be the amplitude for that. Okay, you're looking at the vertical component, so the y coordinates. So here we know that our amplitude is going to be the difference between the maximum and the midline. So if we took our maximum, negative 4.7, and we subtracted the midline, which is negative 7.4 from that, and simplified, subtracting is equivalent to adding the opposite. And so if we took 7.4 and subtracted 4.7, we get a total of 2.7. And so that would be our amplitude. All right, questions about that? All right, so we've now looked at all the different components of the sine and cosine functions. And so what we're going to look at next is how do we put them all together, and how would you be able to either sketch a graph or identify the equation if you have a graph. Okay, so let's look at this one here on the left. All right, so here's sort of the process to begin. Okay, the first thing that you want to do here is, if you recognize your max and your mins, okay, find what the midline is going to be. Okay, so if we wanted to find the midline here, midline is your D value. Okay, so what is halfway between 10 and -2? Okay, so if you add those together, 10 plus -2 is 8. Divide that in half, which is 4. And so you get this midline of 4. And so you know this is your midline. Okay, once you find the midline here, so here as far as our equation is concerned, and it wants us to use f of x equals, so make sure you do type that in. So it's some multiplier. It did say it wanted it in terms of sine, so we know it's going to be something sine of some quantity, plus or minus. Well, we know that plus or minus is our midline. So we can put in our 4 right here. So there's step 1. We find our midline, and we enter that as part of our equation, or establish that as part of the equation. And the next thing we can find here is going to be the amplitude, because the amplitude is the distance from that midline to either the max or the min. And in a graph form, you can usually just count it. Okay, so if I count the distance from 4 up to 10, or from 4 down to -2, what's that total distance? 6. Okay, so the next thing is to find the amplitude. Okay, now, notice I didn't put a sign here yet, and I'll talk in a second about what you can use like for signs. There's more than one right answer when you enter these. Okay, so right now we're just establishing one of the possible answers is an amplitude of 6. Okay, it is also possible to use an amplitude of -6, okay, depending on what part of the graph we choose to sort of shift. Okay, but there's the first 2 parts to sketching this. Bless you. Okay, the next thing that you're going to do is you're going to find the period. Okay, and so when you find the period, what you can do is look to see, since I have a clear point where it passes, and we're using sine, remember, so the sine graph, when you're plotting the points, starts at the midline, and then a maximum, then the midline, then the minimum, and then back to the midline. So that's the sort of the 5 critical points for a sine graph. So when I look at this, I'm going to find a point where my graph crosses the midline, since the sine asks for that. I'm also going to find the point, if I can, where that sine is going up to the maximum. Because this right here, if it has the pattern midline, maximum, midline, minimum, midline, this is the pattern for a positive sine. So I know that my amplitude, I keep it as a +6 here. Okay, and so what I want to do is I want to see what is 2 pi away from this. So when I look at pi over 3, I can go all the way to 5 pi over 3. And that gives me a total of 2 pi. Okay, and because when you find the period, you're doing that to determine the b value. Remember, b is the number of cycles that happen in 2 pi. Okay, so the b value, which is the multiplier in front of the x, right? So it's this number right here. If you had your x minus, sort of the generic form here, we're looking for that multiplier in front of our x. That's the b value, the number of cycles over 2 pi. Well, here, when I see this from the -pi over 3 all the way back to this interval over here, that's 1 complete cycle of my graph. So that means my b value is a 1 for this. So I have a 1 here. I don't need to write it. I'm simply writing it to establish why that's the case, why that's a 1 right there. Okay, and then the final thing I need to do is I need to see my phase shift, right? So to find my phase shift, okay, when I look at this graph, which was normally at 0, right, for a sine graph, it got shifted to the left how many units? It got shifted minus pi over 3, right? That's my phase shift. So that's what's going to go right here. Minus pi over 3 is my phase shift. So what this means is my overall equation, when I put all of that together, is I get 6 times the sine of x minus a minus is plus pi over 3, all plus 4. Okay, so this is the equation that represents the graph that was shown right there. Okay, now, this is not the only equation. Okay, so let me go through and show you what happens if you chose a different interval to count. Okay, so what if instead of going from negative pi over 3 to 5 pi over 3, what if you started right here at negative 4 pi over 3? If you started over at this point, then we went down, midline, max, midline. So now it was the reverse of this. If it's the reverse of that, what you wind up doing with your equation is it's a reflection across the x-axis. So you put a negative in front of the whole function. So this one would have a negative 6 times the sine of. The period, or the b value doesn't change. The midline doesn't change. The amplitude doesn't change. Only the sign in front of the amplitude. And we also have to adjust the horizontal shift or the phase shift, because now we shifted it how far to the left? We shifted it a total of minus a minus, so plus 4 pi over 3. So this form right here would also work. Those are two equations that represent that graph. And now, we could also represent this graph as a cosine function. I'm not going to do it here, but like you can, when you're given these, you can use either sine or cosine. This one specifically asks for sine, so it's looking for that form. Okay, but if it doesn't say, if it just says write the equation of this graph, okay, then you can use either sine or cosine. Okay, so I want you to see if you can extend the same rules here, these same 4 steps, and can you write the equation of this graph here in terms of cosine? And remember, the cosine has the pattern of starting at the maximum, midline, minimum, midline, maximum. That's one period. Okay, see if you can find all the pieces that fit into the cosine graph for that. All right, so there's all the pieces that I need to find, right? It's my A value, my B value, my C value, my D value when we're looking at just the generic equation. All right, so first I want to find this D value, that vertical shift on this. So if I find my maximum at 2 and my minimum at negative 8, find halfway between that. So 2 plus a negative 8 is negative 6. Negative 6 divided by 2 is negative 3. So negative 3 is my midline. Okay, and so that's the first element that I can find. From there, I'm going to use the information for amplitude. The amplitude is the difference in height between the midline and the maximum or the minimum, either one. They should both be exactly the same. So I'm just going to count them, right? From negative 3 to negative 8 is a total of 5 units. From negative 3 up to positive 2 is a total of 5 units. And so my amplitude is going to be 5. Now, I haven't determined yet whether I'm going to use a positive 5 or a negative 5, and I can use either one. It all just depends on, am I going from maximum to maximum for my one cycle, or am I going from the reverse of that, where it goes from minimum to minimum. So I'm going to start with max to max, since that's sort of the basic form. Okay, so if I find the maximum, and I find what is the total distance here of 2 pi. Well, from negative pi over 2 to 3 pi over 2 is a total of 2 pi. How many cycles of this cosine graph are completed during that interval? Just one, right? From maximum to maximum. So my b value is a 1. And so my final step is to find the phase shift. And when I look, this first critical point got shifted pi over 2 in the negative direction. So negative pi over 2 is my phase shift. And that's going to give me my overall equation when I put this together. F of x is equal to 5 times the cosine of x minus a minus. So plus pi over 2 all minus 3. Now, once again, what if I had gone from this point, let's say here, to here? Here is 2 pi units with 1 cycle, but it starts at the minimum on this. So if I'm taking, instead of the max to max, if I'm taking the reflected version of that from minimum to minimum, then what's going to happen is my amplitude is going to have a negative sign, or still be 5, but the negative sign in front means that I'm starting at a minimum instead of a maximum. Everything else stays the same, the b value stays the same, the midline stays the same. The only change that happens in addition to the negative sign in front is the phase shift. And for this one, I shifted it how far? Pi over 2. So x minus pi over 2, that would be my equation. Now, that's also not the only version of that I could have had, right? What if I had used this transformation here? That's also a total of 2 pi with a 1 cycle in that interval. And if that was the case, if I wanted to write that equation, I'd get negative 5. Again, I'm starting down here at a minimum. Cosine of x minus. My horizontal shift or the phase shift is the 1 change. And when I look at this shift here all the way to this point, it's minus 3 pi over 2. So all of these here would be acceptable answers for this graph. Right? Every one of them will work. Right? And in addition to this, again, if you had found this interval from here to here, what could we have used for this? When we go from midline to midline in one complete cycle, that's a sine, right? So if it didn't specify to write this in cosine, let me give you one final version of this. The amplitude stays the same, but what if I use sine instead? The b value stays the same, and the midline stays the same. Okay, but if I had chosen to use the sine here, my sine goes from midline to the minimum. So do I leave a positive in front or change it to a negative? I would change that to a negative, correct? And was there any horizontal shift here? No, it started at the 0. So I could also have written this equation where that's just the x, right? There's nothing, no horizontal shift at all. That would also be the equation of that exact same graph. And I could have, once again, I could have used this portion, this interval. If that was the case, I would use a positive 5. Let me go through one final form of this. If it didn't specify, I'd have a 5 times the sine of x minus something minus the 3. And this would have been a phase shift of negative pi. So x minus a negative gives me a plus pi. Because it went from midline to positive, I'd have a positive sign in front of my amplitude. And so all of these here would be correct answers that give you the equation of that graph. Okay? So it's all going to just be what you see or what's being asked, right? Now, this one specified cosine, so it would require you to write cosine in there, so it would expect to see one of these versions here. All right. So I want you to try this one here on your own. Notice on this one, it didn't specify sine or cosine. The nice thing with the MyOpenMath system is if you use the right form, even if it's one that's not the more common one, it will accept that as correct. Okay, you do need to look carefully on these. And sometimes the grid lines match up to the intervals, and sometimes they don't, right? The radian measurements. So here the grid marks don't. The grid marks are still like integer values, but they're kind of set on top of these irrational intervals. Okay, so what you need to do is you need to pick points that you are relatively confident about where the intersections fall. Okay, what are the x-coordinates of those intersections? We are trying with cosine. Okay, how many are using sine? Okay, I'm going to do both, but I just wanted to kind of get a general sense. Okay, so the way that I would find this is, like, to me, cosine works easiest if you can see, because it's easier for me to find maximum to maximum, right? Now, when I look at that one cycle through, okay, what I can do is I double check. What is the total distance between one cycle? So negative 5 pi over 4 to 3 pi over 4 is 8 pi over 4, which is 2 pi. Okay, so that makes it really nice, right? My b value is 1. I know this, so it makes it nice and convenient. It won't always be the case. Okay, so the next thing to do is to see, can I see exactly where these intersections lie? And I can. Okay, so I know what those, I know what the phase shift is going to be. So cosine to me is going to work pretty easily for this. So when I write this out, I'm going to use, again, I don't know my a value yet, but I'm going to use cosine. My b value is 1, so I can just leave that as an unwritten 1 here, x minus something. And I can find my different elements here. Okay, so let's find our midline. So I have a maximum at 1 and a minimum at negative 7. So if I want to find the halfway point between those, 1 plus negative 7 is negative 6. Divide by 2 is negative 3. So there's my midline, meaning negative 3 is my vertical shift. Okay, and my amplitude is going to be the distance between the midline and my max or min. So if I take the distance, and I will generally just use, if my midline's a negative, I'll go to a negative. So negative 3 to negative 7 is a total distance of 4. So there's my amplitude. I'm not going to worry about the negative sign yet in front, because I'm going to use that in my next step here, which is the phase shift. So with my phase shift here, I'm shifting to the left, and I get a maximum. So since I'm starting at a maximum, this will be a positive number in front, so I'll leave that as a plus 4. And my phase shift is a minus, so change the sign here, 5 pi over 4. And so here would be my answer based on that cosine. Now, I could have done this as a cosine and using this point and this point, right? This is also 2 pi. If I used that, my equation would still be an amplitude of 4, would still be a cosine, would still be a b value of 1, would be x minus. My phase shift is going to change, and my midline is still a negative 3. So the only thing that is going to change potentially would be the sign in front of here and the phase shift. Okay, so I started at a minimum on my cosine graph, so the minimum means I need to put a negative in front of my a value. And then my phase shift here is going to be pi over 4 in the negative direction, so minus pi over 4. So this is another acceptable answer for that graph. Okay, what if you found it in terms of sine? So in terms of sine, we're looking at this point. Now, when I start to look at that, it would have to come all the way here, and I don't see where that intersects. So I'm going to go to this intersection, and it's going to cycle one time through here. Okay, so there is one cycle of my wave. And I do see that that goes from negative 3 pi over 4 to 5 pi over 4, which is 8 pi over 4, 2 pi. Again, we anticipate the period is going to be the same no matter which group you take. So my b value is 1. So if that's the case here, I'm going to write this as sine x minus, again, my midline is still the same. My amplitude is still the same. The only difference might be the sign. Well, when I look at my sine graph, my positive sign is midline maximum midline. This one goes midline minimum, so what do I need to put in front of the 4? A negative. And what is my phase shift here? 3 pi over 4 to the left, so minus a minus gives me negative 3 pi over 4. Okay, so based on what you see in this graph, and where the intersections are, where where you can see the things that are labeled, these would be the 3 options that you have.
Could you explain why you chose to go when it was negative 3 on the phase shift instead of the y-axis negative 3?
So you're always going to start from the y-axis on a phase shift. So like when I looked at this first one here, the first one, this phase shift was all the way here. So it was negative 5 pi over 4. Got shifted. So that's why it's an x minus a minus 5 pi over 4. When I looked at the second one here, plus 1/4, the phase shift was to this point right here, down here, sorry, right here. So it shifted only to the negative pi over 4. So that was the second phase shift. And then the final phase shift here was all the way to this, which is the negative 3 pi over 4. So the phase shifting is always taking place from that y-axis. Other questions? All right. So the last element we're going to pull into this is, what if our b value is something different? Okay, so we've now covered everything that you can see with the easy form where our b value is a 1. Okay, and so the last thing that we need to do is to look what happens when your graph is condensed and tighter, where it has a b value that's some other number. All right, a couple things to point out here. Okay, notice when it says the sinusoidal, it means cosine or sine. You can use either one. Okay, now, based on the dots that you see, this one here on the left, the dots on the midline, so which equation are you probably going to use, or which function? Which of the functions starts on the midline? Sine. So you're probably going to use sine. That's a good indicator that you should use sine. When your point that you see lies on the maximum or minimum, again, which function should you use? Cosine. Okay, so that's the general rule. But I want you to see if you can follow those same set of rules, because I gave you all the same, or all the rules that we just did is exactly the same here. The steps are exactly the same. The only difference here is that when you find the b value, it complicates things a little bit, right? You do have to calculate and find what your b value is, and then that changes only that one part. Everything else, all the other elements, you can find using the exact same steps as what we did on the previous couple slides. Now, also, I talked about this last time. Do you see how the graph on the right is pretty inconsistent with the wave function curves? And anticipate that is supposed to go up to your maximum of 4 and down to a minimum of -6 for every one of those. Right? That's what it's supposed to look like. There's just some glitchiness when you squeeze the sine graph together and how it's represented. Okay, but just try the one on the left. See if you can find that equation written as a sine. Okay, so the easiest thing to find first is the midline. My midline, I see it gave me a point on that midline, so -4. So I can plot that. Next, I can find my amplitude. Okay, the distance from -4 to -10 is a total of 6 units. I'm not going to put a sign there yet, until I figure out how I'm going to, or which phase shift I'm going to use for this. Okay, but for the most part, just to make it the easiest here, I'm going to use the phase shift where the given point falls. So the first one I'm going to use is this one. So based on looking at that one cycle, is my 6 going to be a positive 6 or negative 6? Goes from midline to maximum, so that's going to be a positive, right? So I could leave my sign there as a positive 6. And the next thing I want to do is I want to find, so I can actually look here. My phase shift is easy to see too, right? So it's 5 pi over 4. So I can fill that part in as well. So the only thing that I need to find now is my B value. And remember, the B value represents the number of cycles that occurred during 2 pi, at an interval of 2 pi. So if I come up here to the one that I know, 5 pi over 4, if I go to the left 2 pi, so from here to here is 5 pi over 4, how many pi over 4 do I need to go beyond this to get to 2 pi? I need to move over. I have 5 fourths. I need 3 more, right? So I need 3 pi over 4 more, so I go all the way to this point right here. So this is the interval that you're counting. Okay, so from negative 3 pi over 4 to 5 pi over 4, how many cycles happened? Well, here if I count this through, I go, here's 1, here's 2, here's 3. So what I see is in that span of 2 pi, I had 3 cycles. So what's my B value? 3. And that is my answer. So this is what you would enter. You don't need to expand it out. You could say 3x minus 15 pi over 4, but there's no need to. Just leave it in this form. It's nice and easy. It gives you all the information that you need to know for that. Okay. So that would be my equation. Now, is this the only phase shift that you can write? No. Okay. I could have kept everything the same, except I could have used a different phase shift. I could have used, now this one I don't see, right? I don't really see where that lines up. This one I do see. It's at pi over 4. So I could have shifted here. So I could have said minus pi over 4. I could have shifted to this one at pi. Okay. I could have shifted, again, like any of these that you can see exactly where the point lines up on the midline, you could use that as your phase shift. Okay. But for what we see right here, these would be the most likely versions. And again, you just need to, or for this one, let's say the pi over 4 one. If I use pi over 4, where did my graph go? This is the interval that I'm looking at. Am I looking at a positive or a negative sign? It goes from the midline down, so I would need to change this to a negative. Okay, so if I did use that as my phase shift, okay, then I would need to change the sign in front to the negative 6. All right, I want you to try this last one using cosine, okay, based on anything if you didn't quite get it on the previous time. See if you can use that information to help you find this new function. All right, if we start working through, okay, we're given a minimum. Okay, if we take a distance between the max and the minimum, from negative 6 to 4 is 10. Okay, that means that the midline is going to be half the distance between that. So we can go 5 units up. That gives us the midline here at negative 1. We could also find the average of those, right? So negative 6 plus a 4 is negative 2. Divide by 2 is a negative 1. Either of those ways, we get our midline to be negative 1. Okay, if I'm going to use the phase shift right here, I can see that this is 5 pi over 4. So I can go ahead and fill that in as well. The distance from my max to my minimum I'm sorry, from my midline to my minimum, from -1 to -6 is a total of 5. Okay, and so because I'm starting down here for my phase, if I use the shift of -5 or the x minus 5 pi over 4, I need to put what sign in front of the 5? Because we started at the minimum, it's a negative cosine. And so the only other thing that I need to do here is what students find the most challenging, which is to find that b value, right? Well, again, b value is the number of cycles that happen during 2 pi, an interval of 2 pi. So if I have 5 pi over 4, I need to go all the way to where? -3 pi over 4. So this is a total of 2 pi. And then I count how many cycles happen during this. Well, a cosine from a negative cosine cycle goes from minimum to minimum, right? So here's 1, 2, 3, 4, 5, 6, 7, 8, 9. Once I find what my number of cycles is, that is my solution. And again, you can use different shifts from this. Okay, probably the next one that would be the most accurate would be here. If we come all the way over to this shift right here, it's still a negative, so we go -5, the amplitude doesn't change, the b value doesn't change, the phase shift does change, the midline doesn't change, the vertical shift. Okay, but this is a -3 pi over 4, so minus a minus becomes a positive 3 pi over 4. So this would be two possible solutions. Again, there are others as well.